Have you ever ridden a Ferris wheel, watched a helicopter fly, or noticed how the hands of a clock keep moving in a circular motion? All of these involved in a special type of motion called uniform circular motion. Today, we are going to learn what uniform circular motion is, its characteristics, role of centripetal force, and some real-life examples that we encounter every day. So what is uniform circular motion? Uniform circular motion is the motion of an object moving in a circular path at constant speed. Let us break down the meaning. Uniform means constant. Circular means moving in a circle. Motion means movement. So the first characteristic is circular path. This means the object follows a circular route around a fixed center point. For example, the blades of a helicopter rotate around the center. The second characteristic is constant speed. In uniform circular motion, the object moves at the same speed throughout the motion. For example, imagine a car moving around a circular track at a steady speed. The car continues moving around the circle without speeding up or slowing down. Even though the direction of the car changes as it turns around the track, its speed remains constant. That is why the motion is called uniform. The third characteristic is changing direction. Even if the speed remains constant, the direction changes continuously because the object is moving around the circle. You can think of it like this plant from Plants vs. Zombies. Or for example, when a ball tied to a string spins a circle, the ball changes direction every movement. Because direction changes continuously, the object is still accelerating. The fourth characteristic is the presence of centripetal force. Centripetal force is the force that keeps an object moving in a circular path. The word centripetal means center-seeking because of the force always points toward the center of the circle. Without centripetal force, the object would stop moving in a circle, instead travel in a straight line. To understand this better, imagine swinging a ball tied to a string. As the ball moves around the circle, the string continuously pulls the ball inward towards the center. The centripetal force constantly changes the direction of the ball, allowing it to continue moving in a circular path. If the string suddenly breaks, the ball will no longer move in a circle. Instead, it will fly away in a straight line because the inward force disappears. This happens because objects naturally move in straight lines, unless a force changes their direction. Centripetal force does not push the object forward. Instead, it pulls or directs the object inward toward the center of the circle. Different types of forces can act as a centripetal force depending on the situation. For example, tension from a string keeps a spinning ball moving in a circle, or friction helps cars to turn on curved roads. Here are some simple real-life examples of centripetal force. So first is the roller coaster. The tracks pulls you inward so you don't fly in loops. Next is the washing machine that the drum pushes clothes inward while water flies out. Next is the satellite. The Earth's gravity pulls it inward to keep it orbiting. And lastly is the merry-go-round. The seat pulls you toward the center while you spin. So the formula of centripetal force is F sub c is equals to mass velocity squared over radius, where F sub c represents centripetal force, m represents mass, v represents velocity or speed, and r represents the radius of the circular path. This formula shows that the centripetal force depends on the mass, speed, and radius of the object's motion. So the importance of uniform circular motion. Uniform circular motion is important because it helps us understand how many machines and natural systems work. It is used in amusement park rides, satellites orbiting Earth, washing machines, electric fans, and transportation systems. Understanding this concept also helps engineers design safer vehicles, roads, and machines. So to summarize, uniform circular motion is the motion of an object moving in a particular path at constant speed. We also learned that the centripetal force keeps objects moving in a circle and prevents them from traveling in straight lines.